So let us continue the proof. So we have shown that if f is measurable, then supremum of integral phi of x dx that will be equal to infimum of integral xi of x dx. Now we'll show in the other way. So if supremum is equal to infimum, we show that the function f is measurable. So let us assume that supremum phi less than or equal to f integral over e phi x dx that is equal to infimum over xi greater than or equal to f integral xi dx. So let us take this equal to a common value k. Now we need to show that f is measurable. Here supremum of phi less than or equal to f integral over phi dx this is equal to k. For every phi n less than or equal to f, we can find an n such that integral phi n will be greater than or equal to k minus 1 by n. So you can find an n such that the integral greater than or equal to k by 1 minus n ആയിരിക്കും. And അതുപോലെ തന്നെ infimumത്തിന്റെ കേസിൽ so we know that infimum integral xi is equal to k. So for the case of xi n, you can find an n such that for xi n, integral xi n will be greater than k. You can find an n such that integral xi n will be less than k plus 1 by n. So we can find an n such that k plus 1 by n integral over xi n dx will be less than k plus 1 by n. So we have these two results. So you can find an n such that integral over e phi n will be greater than or equal to k minus 1 by n, and integral over e xi n dx will be less than or equal to k plus 1 by n. Now take the difference of integrals xi n and phi n. So that will give k plus 1 by n minus k minus 1 by n. With k cancel out, we will be getting 2 by n. So integral xi n dx minus phi n dx will be less than or equal to 2 by n. Now let us define phi star to be supremum of phi n and xi star as infimum of xi n. For supremum, infimum measurable functions ആയിരിക്കും. So since each phi n and xi n are measurable, its supremum and infimum are going to be measurable. Okay. അപ്പോൾ phi star and xi star measurable ആണ്. Now f lies between phi star and psi star. So we will have phi n less than or equal to f less than or equal to xi n. So supremum of phi n will be less than or equal to f less than or equal to infimum of xi n. So that will give phi star less than or equal to f less than xi star. Now if you can prove that phi star and xi star നമ്മൾ കണ്ടു measurable ആണ്, കാരണം supremum infimum ആണ് measurable ആണ്. So if you can prove that phi star is equal to psi star almost everywhere, then that will be equal to f almost everywhere. So either phi star will be less than or equal to f less than or equal to psi star for all x. So if phi star is equal to psi star almost everywhere, then for a function f satisfying this condition, f അതിനോട് equal ആയിരിക്കും almost everywhere. So ഇത് രണ്ടും measurable ആയതുകൊണ്ട് we can conclude that f is also measurable. So that is what we are going to do in the proof. So we will show that phi star and psi star they are equal almost everywhere. So f will be equal to these functions almost everywhere, and since these are measurable, f is going to be measurable. So let us now prove the fact that phi star is equal to psi star almost everywhere. Now let us look at the set where this property does not hold. So consider the set of all x such that phi star of x not equal to psi star. So since phi star is equal to psi star almost everywhere, അങ്ങനെയാണെങ്കിൽ ഈ സെറ്റിന്റെ measure 0 ആവണം. So measure of set of all x such that phi star not equal to psi star must be equal to 0. So to prove that this is equal almost everywhere, it is enough to show that measure of this set is equal to 0. ഇനി നമ്മുടെ phi star എന്ന് പറയുന്നത് that will be the supremum value and psi star will be infimum, and the supremum of phi n will be always less than or equal to infimum of psi n. So we'll have phi star less than or equal to psi star. അപ്പോൾ ഈ സെറ്റിനെ നമുക്ക് നോട്ട് ഈക്വൽ ടു എന്ന് വരുമ്പോൾ നോട്ട് ഈക്വൽ ടു നമ്മൾ പറയുമ്പോൾ ഒന്നെങ്കിൽ phi star greater than psi star ആവാം, അല്ലെങ്കിൽ phi star less than psi star ആവാം. So by the definition of phi and psi, phi star and psi star, so phi star will be always less than or equal to psi star. So it is enough to show that measure of this set is equal to 0. അപ്പോൾ ഈ സെറ്റിനെ നമുക്ക് ഒന്നുകൂടെ ചെറുതാക്കാം. So you will not have the greater than part in it. So it is enough to show that measure of set of all x such that phi star of x less than psi star is equal to 0. Now let us write the set delta as set of all x such that phi star of x is less than psi star of x. So we have delta equal to this set. We need to show that measure of delta is equal to 0. So നമ്മൾ ചെയ്യാൻ പോകുന്നതാണ് we'll express delta as a countable unit of measurable sets, and then we'll actually show that its measure is equal to 0. If x belongs to delta, that implies phi star of x is less than psi star of x, and then we can find a positive integer v such that phi star of x is less than psi star of x minus 1 by v. So we can find v such that this happens. So phi star of x less than psi star of x minus 1 by v. And delta can be written as a union of v equal to 1 to infinity set of all x such that phi star of x less than psi star of x minus 1 by v. Now I'll call each of this set as each set delta v. So delta will be equal to union of v equal to 1 to infinity delta v. Now നമുക്ക് prove ചെയ്യേണ്ടത് measure of delta equal to 0. So if you can show that the measure of delta v, each delta v is equal to 0, then subadditivity property measure of delta will be less than or equal to summation measure of delta v. So if each measure delta v is 0, so we'll get m delta less than or equal to 0. അങ്ങനെയാണെങ്കിൽ m delta 0 ആവണം, since measure is always greater than or equal to 0. So we will now show that m delta v is equal to 0. Okay, അപ്പോൾ നമ്മുടെ സെറ്റിനെ നമ്മുടെ ഒറിജിനൽ സെറ്റ് ഡെൽറ്റ എന്ന് എടുത്തു, ഡെൽറ്റ നമ്മൾ യൂണിയൻ ഓഫ് ഡെൽറ്റ വി സെറ്റ് എഴുതി. സോ വി വിൽ നൗ ഷോ ദാറ്റ് measure of delta v is 0. So that is the next step. So prove that m delta v is 0. Now on delta v we have this condition. Delta v നമ്മൾ ഡിഫൈൻ ചെയ്ത phi star of x less than psi star of x minus 1 by v ആണ്. Now phi star is the supremum of all phi less than or equal to f, and psi star is the infimum over all psi greater than or equal to f. So each phi n will be less than or equal to phi star. Phi star less than psi star minus 1 by v ആണ്, and this will be less than or equal to ഇത് infimum ആണ്. For any arbitrary psi n, this will be less than or equal to psi n minus 1 by v. So now take the difference of these two. So psi n, so take the first and last term here. So we will get psi n minus phi n greater than or equal to 1 by v for all n. And now the corresponding integral on both sides with respect to delta v on the set delta v. The integral since psi n minus phi n greater than or equal to 1 by v, so integral over delta v psi n minus phi n dx will be greater than or equal to 1 by v dx. So integral over 1 by v is a finite value. This will be integral over delta v dx. The integral over delta v dx that will be the measure of the set delta v. So we are going to get 1 by v m delta v less than or equal to integral over delta v psi n minus phi n dx. Delta v v യുടെ subset ആണ്. So we can write it as less than or equal to integral over e psi n of x minus phi n of x dx. So that is integral over e psi n dx minus integral over e phi n dx. Now this difference we have already shown in equation 2 that this will be less than or equal to 2 by n. So we'll get 1 by v m delta v less than or equal to 2 by n. So therefore m delta v will be less than or equal to 2v by n for all n. So therefore this must hold as n goes to infinity also. So when n approaches to infinity, this value goes to 0. So m delta v must be equal to 0. So we'll get m delta v equal to 0. That is the measure of set of all x such that phi star of x less than psi star of x that must be equal to 0. So if m delta v is equal to 0, then the m delta value 0 ആയിരിക്കും. M delta value 0 ആണെങ്കിൽ that means here the function phi star will be equal to psi star almost everywhere. So we have phi star less than or equal to f less than or equal to psi star. So that implies this will be equal to f almost everywhere. Phi star and psi star supremo infimo ayadondu measurable ആയിരിക്കും. And if it is equal to a function almost everywhere, that function also will be measurable. So that proves the fact that f is measurable. So this completes the proof for the proposition. Now let us define what is a Lebesgue integral. Okay, അപ്പോൾ നമ്മൾ കണ്ടു function measurable ആണെങ്കിൽ നമ്മൾ supremum infimum equal ആണെന്ന് കണ്ടു. So if f is a bounded measurable function defined on a measurable set E with measure of E finite, then this integral is called as the Lebesgue integral. So the Lebesgue integral of a bounded measurable function is integral over E f dx. So that will be equal to supremum over phi less than or equal to f integral phi dx or infimum psi greater than or equal to f integral psi dx. Given an integral of the form integral capital F f dx. So that is integral f into chi of f dx, where f is a measurable set of E, and in the case where f is equal to an interval, in that case the integral is defined as integral over f dx. So that is written as integral a to b f into chi of ab dx. So this is how we denote the integral over closed interval ab.